We can get started. My name is Harold Trinkunas, Deputy Director here at the Center for International Security and Cooperation and co-instructor in the Honors Seminar this year. Glad to welcome you all to the final set of presentations of this CSAC Honors Thesis program. We're going to start with Isobel Porteous, who's advised by Professor Simone D'Amico from the Aeronautics and Astronautics Department. Over to you, Iso.
I'm Isobel. I study aeronautics and astronautics, and I'm thrilled to be here today to present my CSAC honors thesis. My advisor was Simone D'Amico, and I want to thank him and the entire CSAC team for making this an incredible experience for me. I also want to start my presentation with just some context that space technologies are critical to the way that we all live every day, whether or not you see them, but that space is a warfighting domain, and the placement of weapons in space threatens technologies that we all rely on. The United States assesses that Russia is developing a new satellite carrying a nuclear device. This information was disclosed by Biden's National Security Advisor, Jake Sullivan, during a White House press briefing last February. The US Space Force tracks 47,800 space objects today. So this development invites the question, if such a weapon were placed in outer space, how would we know it was there? How would we monitor for the presence of such a device in orbit? The placement of a nuclear weapon in space directly violates Article 4 of the Outer Space Treaty, as well as a UN resolution adopted in 1963. Typically, and at the time that the bomb ban was first adopted, the United States holds a strong position in arms control agreements that we try to only accept verifiable agreements. And yet, curiously, the Outer Space Treaty doesn't have any cooperative inspection regime or any explicit verification mechanism at all. With this context, for the last year, I've studied the ability to monitor and inspect for the presence of nuclear weapons in outer space. My thesis examines the technical feasibility of looking at in-space inspection and missions capable of detecting the presence of a warhead on board an orbiting satellite, as well as the political feasibility of using such missions to verify the ban on bombs in orbit. Simply put, I look at the question of whether it's possible to take one inspector satellite, fly it up close to another satellite in orbit, and see whether that second satellite is carrying a warhead on board, which would constitute a treaty violation. There were three key dimensions to my research. I'll talk today about the performance of nuclear material detectors in outer space, the spacecraft guidance, navigation, and control techniques that can be used to fly inspection missions on orbit at proximity to a target, and then the historical record on why we had or didn't have inspection at the time that the Outer Space Treaty was adopted based on archival findings from the LBJ archive in Austin. So there are a range of technologies out there today for detecting nuclear weapons. They range from passive systems to active systems, intrusive schemes versus visual inspection methods. I surveyed a huge swath of these during my literature review and landed on two for further study. I look at one active system and one passive system. The active system I selected is X-ray radiography, and this forms the focus of my first simulation. To conduct my first simulation, I built a desktop application on my laptop in C++ that simulates in-orbit inspection using a software package that I found that was developed at CERN, the particle accelerator in Switzerland. It uses object-oriented programming and Monte Carlo methods and a database of material properties to simulate the motion of energetic photons through different geometries. I'm going to break down what X-ray radiography actually is now. Effectively, it's the same process that happens if you break a bone, you break your foot. You have a source of photons on one side, a target of your scan in the middle, and then a detector on the far side that's sensitive to incident photons. Dense materials like bone attenuate photons as they travel across, and so you get an image that shows the contrast between dense materials and the surrounding environment or the surrounding structure. In the case of my simulation, I was scanning an example target that represents what I think a nuclear weapon in space might look like at a very simple level. I use a two-stage thermonuclear weapon with a plutonium primary and a uranium secondary, surrounded by a very basic spacecraft structure made of aluminum. And I'm happy to talk more about why I made those assumptions in the Q&A. But what's happening here is the photons are firing across the screen through the target, and what you expect to see is an image of what the internal structure of the target looks like. There were a couple of variables that I was able to play with in my desktop app, so I could vary particle energy, the duration of the scan by number of particle events, the divergence angle, which basically just measures the spread of the beam, how wide it is, and then the standoff distance, so the distance from the target to the source and the detector, which was equidistant on either side. Excitingly, my first simulation worked. it showed that X-ray is able to happen in the space environment, in my simulated space environment at the very least. And I was able to image the satellite and detect the contrast between the warhead in the center, that little black dot, and the surrounding environment and spacecraft structure. So that was my first exciting finding. And then looking at the rest of my trials, we can study kind of the optimal specifications for how this system would actually work if you were to launch it. I found that the length of the scan doesn't have to be long. This number of particle events actually represents a number of photons that were generated in the simulation. And with typical flux for any X-ray source, you're able to produce these scans in like the order of microseconds, which means the same scan could happen really quickly in a quick flyby inspection mission in orbit. The higher the photon energy, the more particles are able to penetrate and pass through the target. So in my trials, I found that kind of this range of like 100 keV to 1 mega electron volt is optimal for imaging a satellite over large standoff distances with dense shielding material structures. This is kind of the range of energies that you would find for a synchrotron light source, like the one over at SLAC, which is typically pretty big and power intensive, but there have been recent updates in smaller scale portable X-ray sources that would allow you to produce X-rays of these energies on a spacecraft payload, or at least I speculate so. I want to focus on this variable that was really important, which is divergence angle. So this measures how parallel your beam is. And it's turned out to be super critical in my simulation that if you have a smaller divergence angle, you're able to perform a scan over larger standoff distances. Effectively, the more parallel your photons are, the better the scan. If the beam is too wide, you lose the image. So overall takeaways from the first simulation were that X-ray radiography is indeed possible in space, even over large standoff distances between spacecraft. Divergence angle is certainly very important, and there's going to be a precise alignment requirement of the 3 satellites in your formation flying mission. And then scanning times were really short, which just generally facilitates an easier and faster scan or inspection. I also want to mention that on the divergence angle piece, it's possible to use lenses to adjust the divergence angle of a given X-ray source. So this would be the kind of thing you would do if you were to move on and use this as a payload on a satellite. Having established the X-ray source and detector performance specifications and that they work in the space environment, I turned to the question of how do you design this formation flying mission? What would the trajectory of the satellites look like? You need 3 satellites to do this with X-ray radiography. You need a source, a detector, and then of course the target in the middle. And the 3 satellites need to be aligned. If you simply separate the satellites over the same orbit, in a simple kind of string of pearls, a long track formation flying mission with a separation of 10 kilometers on either side, there's no alignment because of the curvature of the orbit. You can't scan the target in the middle because of that 6-meter difference that you see there. This is again using my target, like example target, which was flying in a 2,000-kilometer orbit. So to account for this curvature in the orbit, I introduced a modification in what we call the relative orbital elements. These are a set of variables that describe the difference in position between 2 satellites, one the target, the other the inspector. And you can see that if you introduce a separation in the radial direction, so you keep the satellites all aligned along that line up at the top. If you keep that separation in the radial direction equal and opposite for each inspector, even with oscillation in the relative eccentricity vector, which measures that distance, that 6 meters, the satellites will remain aligned. So even in the presence of perturbing forces or natural oscillation in the orbit, the alignment stays. This shows that it is indeed feasible to perform inspection with these 3 satellites flying in formation. So now I'm going to discuss my second simulation, which used gamma spectroscopy. The way that I looked at an active sensor, I wanted to consider also a passive option that does not irradiate the target with any energetic particles. This is generally considered safer, simpler, and more secure by arms controllers. Passive systems don't risk any accidental detonation. So gamma spectroscopy relies on a scintillator device. It's a sensitive detector. In my case, I used sodium iodide that's sensitive to incident gamma rays and is able to log their specific energies. Fissile materials like plutonium-239 and uranium-235 emit gamma rays as part of their radioactive decay process. The gamma rays are emitted at known energies and intensities that are summarized in this table. These 8 characteristic peaks will show you the presence of one of these 2 isotopes if they show up in your gamma spectra in large quantities. But the gamma spectroscopy process is complicated by the presence of background or other gamma rays. And in space, this is especially important because there are gamma rays that come from solar flares, from the Van Allen belts, which are naturally occurring belts of radiation in Earth orbit, and interactions with the Earth's atmosphere from charged particles. So NASA and ESA have studied the space radiation environment extensively, and there are models of the space background at my example orbit, 2,000 kilometers, 67-degree inclination, available in a tool called SpenViz. So I imported the space environment data into my simulation to try to get an accurate model of what the background environment looks like in space. The variables I looked at for this simulation were just inter-satellite distance between the inspector and the target, as well as the duration of the scan. Again, excitingly, what I found was that gamma spectroscopy certainly works in space. It's possible to detect these isotopes, or certainly characteristic peaks of these isotopes. What you see in this trial are 2 peaks of plutonium and 1 peak of uranium that I was able to find once I subtracted out the background using an algorithm I designed that's calibrated for the space background. You see just, again, one uranium peak and 2 plutonium peaks here. The thing that I want you to note is that we were looking for 8 characteristic peaks, but the lower intensity peaks, you lose them because of the space background. And it's sort of difficult to claim definitively there is plutonium on board this satellite with just 1 peak, right? But it's certainly a piece of evidence that would aid an intelligence assessment about what's happening on board a subject of an inspection. I found that spectroscopy worked a little bit better at close proximity. So I got 4 peaks shown at distances on the order of 2 to 10 meters, which is considered a very close approach in outer space. I also found that signal to noise is the more important variable and metric for spectroscopy. Longer scans beyond a certain point don't show you more data. You're just getting like a larger number of particles overall. At the kilometer scale, I actually was able to detect 3 characteristic peaks over these longer scan times once I had kind of a representative spectra, which is interesting as a data point. These are much larger standoff distances than you would ever use in gamma spectroscopy on Earth. But this likely happens because there's just no air density in space, and so the gamma rays are able to travel further without scattering. Overall, my gamma spectrum results showed that gamma spectroscopy does work in space, certainly. But many of the characteristic peaks of plutonium and uranium are masked by the expected gamma environment in Earth orbit, and that generally longer scans over like 3 hours won't result in a better detection result. Again, as I did with the X-ray simulation, I turned my attention to how would one design the inspection trajectory for this scan. And I apply a technique called eccentricity and inclination vector separation. So what's happening here is the target of the scan and the inspector are aligned in the along track direction, but the inspector is flying in this helix around the target. So you can see the target's trajectory as the dotted line and the inspector as the helix. And you introduce a separation in the radial and orbit normal directions so that the inspector satellite is staying separated from the target. The two trajectories will never collide. And both satellites are safe from collision on orbit. So what this shows is effectively that modern spacecraft GNC techniques allow us to design these passively safe trajectories where even without active propulsion, even with the failure of the propulsion system, the satellites will remain separated safely, even at close standoff distances. And this is something you wouldn't have had or been able to do successfully in the 60s, but that's possible with state-of-the-art research being done here at Stanford. And just to wrap up my technical section, both systems worked in outer space, but the trade-offs are that the X-ray system is faster, works further away, and shows you more information about the target, where the gamma system takes longer, scans need to be closer, and give you only a limited amount of information about the fissile isotopes that might be on board. Both inspections are possible to design safely with modern GNC techniques. Here I'll begin sharing the historical narrative that I found, the final set of empirical findings of my thesis, which were uncovered at the LBJ archive. So I looked at these top secret documents that were only declassified in like 2011 and really haven't been written about elsewhere that discuss the 1960s military space program. In the 60s, the US and the Soviet Union were both testing high altitude nuclear weapons, and the US performed an experiment called Starfish Prime, which destroyed roughly 1/3 of satellites in space at the time it went off. and left an EMP blast in space that lasted for the next 5 years. This problem was exacerbated by propaganda that the Soviets were putting out, like this telegram from Moscow to Italy saying that the US was developing a nuclear sword of Damocles that was going to be put in space and incinerate entire continents. So to deal with this kind of international political backlash against the US military space program, Kennedy created a top secret committee called the NSAM 156 committee. And they delivered a lot of policy recommendations that defined our early space program and our early space policy. They had a massive internal dispute about the ban on bombs in orbit. They really couldn't decide if this was a good idea or not. Ultimately, the committee wrote these pro-con lists and recommended to Kennedy that we not support a ban on nuclear weapons in space, mostly because the US was just beginning our spy satellite program, and particularly the Joint Chiefs of Staff and the CIA could not, under any circumstances, allow inspection of US space vehicles because they didn't want the world to know we were building these early spy satellites. And we couldn't imagine any kind of arms control agreement without verification or inspection of space vehicles. So unusually, President Kennedy actually rejected this unanimous recommendation from his own committee. He said, I strongly support a ban on bombs in space. And Kennedy himself was the one to question whether we needed to insist on inspection and verification in this new arms control agreement. McGeorge Bundy wrote a memo saying Kennedy questions whether our position on insistence on inspection must be maintained on all subjects. And this was sort of the historical anomaly that I found relative to other arms control work at the time. At this point, before anything can go further, the Cuban Missile Crisis intervenes, which totally put a stop to arms control negotiations with the Soviets. And in the place of the conversation about disarmament in space, the US started building up our first counter space weapon systems, and these are pictured on these slides, these direct descent ASAP programs. We also created a program, though, called Program 922, which proposes exactly what I discuss in my technical section: an orbital rendezvous mission, an inspection mission in space with nuclear material sensors on board to fly by a suspicious hostile satellite and check for the presence of a nuclear weapon. But tragically, Program 922 never launched. There was a hurricane over Johnston Island where it was housed, which destroyed a lot of the computers housing the data about the program. And then the program was canceled, or like they decided not to restart it because of funding priorities related to the Vietnam War. So going back to the negotiations, about a year after the Cuban Missile Crisis, Ray Garthoff, who was a young State Department official at the time, was in Geneva, and he had this kind of back channel dialogue conversation on a walk in Geneva with his Soviet counterpart, Igor Usachev, and they talked about the ban on bombs in space. And Garthoff indicated to the Soviets that the US wouldn't insist on inspection or verification. Usachev kind of responded that the Soviets also didn't want inspection, and that conversation allowed arms control negotiations to move forward. What we ended up with was UN Resolution 1884. This was a UNGA resolution that said that the US and the Soviet Union would agree not to put nuclear weapons in space. Critically, a UN resolution isn't enforceable and doesn't have to go in front of Congress. So there was no opportunity for Congress to debate this question of verification of the ban. It was adopted in this way that was really politically expedient and never put up for debate. So when you move forward to the Outer Space Treaty itself, when the US went to negotiate the OST, the ban on nuclear weapons in orbit had already existed for 4 years as part of US policy, and it was moved into the Outer Space Treaty as Article 4, almost verbatim. And we missed the opportunity to have this conversation about verification and inspection regimes. There was only one senator who asked a question about inspection, Bork Hickenlooper from Iowa, who asked about whether we had a means of verification, and Russ kind of gave this like non-answer, and we ended up just passing Article 4 without any significant political opposition. And that's why the current literature misses this conversation as well, because when you look at the Outer Space Treaty, you miss UN Resolution 1884. So overall, my thesis archival research takeaways were that we adopted the most politically expedient ban on bombs in space. That's why we left out inspection and verification. Ended up being an unverified ban because that was what we were able to agree upon, given the concerns about the secrecy of the space reconnaissance program. I also want to highlight how important like human beings and leaders and diplomats were in this conversation. Like without Ray Garthoff having this relationship with his Soviet counterpart, or without Kennedy having a personal commitment to space arms control, this wouldn't have happened at all. So to wrap up, I'll just share that in the 1960s, I found inspection was not yet technically feasible, was certainly, though, something that we were thinking about and maybe imminent just over the horizon. But even if inspection had been technically feasible, security concerns and political negotiations prevented inspection and verification overall. Inspection is certainly technically feasible, I think, with modern nuclear detectors and innovations in spacecraft GNC. Particularly, we can do this safely now without risking collision, even at close proximity, which is exciting. But even so, I'm left with a lot of concerns and questions about the political feasibility today, sadly. It comes down to a couple of key questions for me. Would this inspection regime, if we did it today, be permissive or non-permissive? Would the target of the inspection consent to the inspection, or would we have this as a national technical means that we did unilaterally? How would you know to tip off the system is another question I have. How would you deal with the possibility of false positives, peaceful uses of nuclear material in space for spacecraft propulsion? And then what would be the international kind of galvanizing moment to all get behind a new updated version of the Outer Space Treaty? Okay. We'll turn to questions.
By CSAC custom, the first question goes to the advisor, Professor Simone D'Amico. If others want to get on the list, just raise your hand and I'll try to keep track. And we have about 10 minutes for questions. And if you're online, use the Q&A function in Zoom. Let's go to Professor D'Amico.
So first of all, Iso, it was an honor to be your research advisor over the last academic year. I mean, this is outstanding work. We chose how the solution of complex problems, I mean, it doesn't lie in mastering the details alone or having the holistic system level view, but it's the union of the two. That's what we try to do in aerospace engineering. So I asked you many questions over last quarters, but something I didn't ask you so far. What would you do? I mean, in the current geopolitical situation, I mean, there have been changes from the 60s, as you said. Okay, technically, we are more advanced and these capabilities are there or very close to be there. But geopolitically, I mean, look at the pushback from the international community when news came up on May the 23rd. We are talking about a week ago. A Cosmos satellite was placed in the same orbit of a US spy satellite, approaching at 100 kilometer distance. Or look at the pushback I get from NASA, for example. I have an experiment in orbit, and I keep seeing Chinese and Russia objects in the images we get from the satellites. And NASA asking me, "No, don't put this on LinkedIn, because we don't want to give the impression that we are spying on them." So the question is, what would you do? I mean, if you had the power as a decision maker in order to make us more safe.
This is a hard question, certainly. So the first thing I'll say is that unlike the Cold War space race, our space race today is highly multipolar, right? There are just more actors with more global dependency on space. And I think that you can see that as an opportunity, right? With more actors who would advocate for space arms control, particularly commercial companies and civil users of systems like GPS around the world. You can argue that an indiscriminate weapon like a nuclear weapon in space is just an existential threat to the way that we all live. And I think that invites an opportunity for a new arms control conversation. I would want this to happen in a permissive way. I think that given what you're saying about the idea that people are spying on each other in space, it's highly inflammatory. We would have to conduct this inspection mission, particularly a close proximity one, in a permissive way where the target knew it was being scanned and we were accepting that possibility. I actually talked to Rose about this. I think our greatest possible ally in a new arms control regime in space would actually maybe be China, which is atypical relative to sort of the usual great power competition conversation. But China, like the US, is highly dependent on their own space systems, and they wouldn't want a nuclear weapon in space any more than we would. And they might be willing to have that conversation.
Great. Okay, I have Herb. I have someone in the back. Yes, last row, and then I have Rose. And I think that might be as much time as we have. We have 6 minutes left. Herb. Microphone.
Great presentation, great thesis. Could you differentiate between a bomb and a nuclear reactor? No, not an RPG. I mean, a real nuclear reactor.
So my simulations only looked at this two-stage thermonuclear weapon that I mentioned. The X-ray system, it would just be a lot better at differentiating a false positive because you get more data. An X-ray scan is going to show you the structure of whatever fissile material is on board, not just the fact that the isotope is there. So to deal with the question of any kind of false positive, I'd pick the X-ray system every time.
And so there was somebody next to Dr. Rodhanovic, and then we'll go to Rose Gottamiller.
Fantastic presentation, Isobel. You touched briefly upon this in your presentation, but could you elaborate upon the target spacecraft and weapons model that you used in your simulation and why you picked the design assumptions that you did?
Yeah, so this was a big part of my research, actually. There are infinite satellites in infinite orbits, theoretically, that I could have studied. I had to make a couple of series of assumptions. So the first was, what does the nuclear weapon look like? And I tried to pick kind of the worst case, least detectable option to say that if this warhead is detectable, then all other warheads are going to be detectable. And I based this on a study that Steve Fetter did in 1960, where he showed that a small 4-kilogram plutonium sphere surrounded by a tungsten shell as a primary is really difficult to detect. And then I chose a 300 kiloton yield uranium secondary based on kind of the low end of what the EMP Commission has studied as possible nuclear weapons to create an EMP effect in space. Then for the satellite itself, this part was interesting. I based my selection of a 2,000 kilometer, 67-degree inclination on public speculation about a satellite called Cosmos 2553. Which was launched around the time that the Russians invaded Ukraine, and has been shown to be connected to high altitude nuclear experiments being carried out by a Russian university in some court documents. So this is obviously super speculative. We don't know that Cosmos 2553 is carrying a nuclear device, but I think these kinds of public speculation, this dialogue would invite a possible inspection, or at least be grounds for an inspection mission. That's why I picked it.
Great. Let's go to Rose Gottamiller.
You have a microphone.
You have mics in the
There-
table.
right. Yep, I'm set. So fantastic evolution of this project, Isobel. Congratulations. And I wanted to do two things. I wanted to first give you a shout out for the important archival research you did. These are undiscovered documents and very impressive from a scholarly point of view. So shout out for that. And also I want to thank you for highlighting the role of Ray Gartov in our early arms control efforts. He was an amazing individual. And the honor of getting to know him. What you mean by permissive a bit.
Yeah.
Do you simply mean non-interference with national technical
Okay, well,
means, or do you mean they cooperate in holding the attitude or adjusting the attitude?
There's a lot of shades of how one could define permissive, right? Ideally, you want a standard set of protocols where we're definitely going to use a passively safe trajectory, and the target of the inspection is maybe once you get within kind of it seems most realistic for me non-interference as a future like this. A defined set of standards where you conduct rendezvous with suspicious targets seems unlikely given current geopolitics.
Great. Well, everyone please show me. And we'll take a minute so there can be some turnover in the room as new people come in, and maybe some people are not staying for the whole 90 minutes before we start the next presentation.
Just like, if you want to hear more about the work of the Johnson Library. You're not, but my therapist here back. Thank you.
For those of you who are departing, if you can take your conversations downstairs so that there's not so much noise in the environment. Tracy, could you? Okay, my pleasure to introduce Noah Tan, who will be speaking on his honors thesis, Signed, Sealed, Circumvented, the Effect of US-China Trade War Tariffs on Patterns of Trade Rerouting. Over to you. I'll speak over about 20 minutes, and then we'll have about 10 minutes for Q&A. As in the past, first question goes to his faculty advisors, advised by Frank Fukuyama, Michael Allen, and Licheng Liu.
Good afternoon, everyone. Thank you all for coming in person or online. My name is Noah Tan, and I'm an international relations major and a member of this wonderful CSAC honors cohort. First, I'd like to begin by thanking the instructors of this course, Dr. Johanna Rodahau-Noack and Dr. Hilton Trinkunis, as well as Dr. Cameron Tracy and Dr. Colin Call for supporting our cohort throughout this year. I'd also like to thank my advisors, Dr. Francis Fukuyama, Dr. Michael Allen, and Dr. Licheng Liu for their mentorship during my thesis writing process. In May 2018, the Financial Times reported that President Donald Trump had declared a trade war with China, citing unfair trade practices. This marked the beginning of a significant escalation in trade tensions between the world's two largest economies. This declaration led to a series of tariff impositions between the United States and China over the following months and years. And by late 2019, the US had imposed tariffs of approximately $350 billion worth of Chinese imports, while China had retaliated with tariffs of about $100 billion of US exports. I specifically want to focus on these tariffs, Section 301 tariffs. These tariffs are China-specific tariffs that the Trump administration launched in 4 tranches between July 6, 2018 and September 1st, 2019. Tariffs are designed to protect American industries and jobs by making imported goods more expensive, thereby limiting Chinese access to the US market and encouraging consumers to buy American products. And in theory, they should work. But how effective were they in this mission? Some would say not so much. Because of this, a strategy known as trade rerouting, also known as transshipment, it's the illicit act of circumventing import tariffs by shipping the affected product to an intermediary country, conducting some minimal processing, then re-exporting that same product to the country that applied the tariff. And multiple countries were accused of being conduits for such practices, such as Vietnam, Thailand, Malaysia, and Mexico, among others, exacerbated by these Section 301 tariffs. So my thesis centers around asking, how did the imposition of Section 301 tariffs truly affect patterns of Chinese trade rerouting through intermediary countries during the US-China trade war? Now, there's been some minimal existing literature on this topic. 2 main studies have previously looked at trade rerouting in response to tariffs. The first one in 2024 by Eo et al., Harvard Business School looked at this phenomenon in response to Trump's trade war tariffs and observed some signs of trade rerouting through Vietnam. However, they only looked at Vietnam and not a systematic rerouting through different intermediary countries as a whole. Meanwhile, Liu and Sher in 2019 looked at US anti-dumping duties on China from 2002 to 2006 and found significant signs of trade rerouting. However, they did not study the US-China trade war, and they also did not look at Section 301 tariffs. So my study combines these 2 methodologies to come up with a novel finding of the effects of these tariffs on trade rerouting through multiple countries during the US-China trade war. Now, to do this, I use two different complementary methodologies. The first is the Ioha et al. Methodology. I first calculate the trade rerouting term called reroute. This essentially calculates the maximum quantity or value of a certain product that could be rerouted through a certain intermediary country. I'll be using a difference in difference estimation, which is a quasi-experimental approach that compares trade rerouting between tariffed products and non-tariffed products before the tariff imposition and after the tariff imposition. Now, I'd like you to focus on this variable right here, treat times post. This term represents how much a product being tariffed affects its level of trade rerouting after the treatment compared to products that were never tariffed. So if there is trade rerouting increases, we would expect to see that this term is positive and statistically significant. Now, given this is a maximum possible quantity or value, it is almost certainly an overestimation. After all, how can we know that it is not just actual trade or actual value added that Vietnam is adding to a specific product? So to make this methodology more robust, I employ a second methodology, the Liu and Schur method. This methodology also employs a difference in difference estimation strategy, but this method, in contrast, is interested in three different things. First of all, it's interested in the exports from China to said intermediary country, the exports from that same intermediary country to the US, and most importantly, the strength or the correlation of this relationship. I want you to focus specifically on this term. It's the log of Chinese exports to the intermediary country times treat times post. Now, this triple interaction term, as I'm calling it, measures how much the tariffs affect the strength or the correlation of this trade flow relationship. So if there is trade rerouting increases, we should expect that this term is positive and statistically significant, meaning that being tariffed and targeted by Section 301 tariffs strengthens the direct relationships of products flowing through country C from country B to country A. So how do I collect data on this? Well, firstly, I look at the database for international trade analysis. This essentially measures bilateral trade flows for 200 countries for about 5,000 different products. Second of all, how do we know which products were tariffed? Well, I comb through thousands of lines from the US Trade Representative's China Section 301 Tariff Actions and Exclusion Process Declaration. It includes the list of products tariffed by their respective product code, as well as which products were later granted exemptions and this excluded from the treatment group. I'm separating these products then by when they were treated, whether in 2019 or 2018, respectively. Finally, the US Trade Representative also has what's known as the Harmonized Tariff Schedule, which categorizes products by their code. More digits signify greater levels of specificity. For example, an HS87 describes vehicles other than railway or tramway rolling stock, while HS870321 describes motor cars and other motor vehicles principally designed for the transport of persons with only spark ignition internal combustion. So you can see the more digits, the more specific the product. So let's just take a step back and recap what's going to happen. So first, I collect bilateral trade flow data, collect data on which products were tariffed and not tariffed, and I separate that into when they were tariffed, either in 2018 or 2019. I then apply the first methodology, which calculates the maximum possible quantity or value of product that could be rerouted, using a difference in difference estimation to see the effect of the tariffs, and most importantly, if we see an effect, that trade rerouting term, treat times post, should be positive and significant. Then to qualify this estimation, I look for the triple interaction term in that second methodology. And most importantly, if there is an effect there, we should see that this triple interaction term, log of Chinese exports, times treat, times post, should be positive and significant. And finally, I look at time varying effects. So how do products tariffed in 2018 differ in their respective trade rerouting increases compared to products tariffed in 2019? So what do we find? Well, we find that yes, there actually is a positive and significant relationship between products that were affected by Section 301 tariffs and their respective increases in trade rerouting. As you see in the first methodology, both in trade quantity and trade value, there is a statistically significant increase in trade rerouting for products that were targeted by these tariffs versus products that were not. However, if you're looking at that second, more robust methodology, you can see that actually the effect is quite minimal, quite modest. in trade quantity, it's only about 0.5%, which in the grand scheme of global trade is non-trivial, but still not that much. If you're looking at trade value over here, you can see that products that were affected by Section 301 tariffs had statistically insignificant increases in trade rerouting. So what's going on here? Let's also look at the time-sensitive differences. As you can see, there is an interesting finding here. If we look here, products that were targeted by the tariffs in 2018 exhibit a statistically significant increase in trade rerouting, but products tariffed in 2019, no effect whatsoever. This is the same in both trade quantity and trade values. You can see here, products tariffed in 2018, statistically significant increase in trade rerouting. Products tariffed in 2019, absolutely no finding. So the summary of this first part is that there is evidence of systematic and cross-national trade rerouting resulting from Section 301 tariffs launched by the Trump administration. But the evidence is quite modest, and the strength of this evidence depends on two factors, whether you're looking at trade quantity or trade value, and when the product was tariffed, either in 2018 or 2019. So this leads me to two lingering questions. First of all, why was trade rerouting increases significant for products tariffed in 2019, but not for those tariffed just 1 year or less later? I call this the cohort heterogeneity issue. Second of all, why was trade rerouting increases captured when observing trade quantity, but not when observing trade value? I call this the quantity versus value issue. So you can see here, I identified 6 potential mechanisms that could explain our questions from before. Most attempt to explain why 2018 products exhibited more trade rerouting, and some, the pass-through mechanism and the product complexity mechanism, attempt to explain that second question, the quantity versus value discrepancy. Now, I'm only gonna, in the interest of time, focus on these first 2 strongest mechanisms, the strategic product mechanism and the close ties mechanism. So to answer these questions, I used the mixed methods approach, applying further regression analysis, news and industry reports, and data from other scholarly sources. Let's turn now to the first mechanism, the strategic product mechanism. In May 2015, Premier Li Keqiang and the Chinese State Council announced a 10-year plan known as Made in China 2025, with the expressed goal of making China a manufacturing superpower by 2049. Now, Made in China 2025 is a national industrial policy to transform China into a global leader in advanced manufacturing by upgrading its manufacturing sector, reducing reliance on foreign technology, and promoting innovation and exports in 10 key high-tech industries. As you can see here, these industries include advanced IT, aeronautics equipment, rail, power, agricultural equipment, and biopharmaceuticals and advanced medical products, to name a few. As you can see here, more specifically, these are the types of products that could be potentially categorized as a strategic product, as well as their respective HS2 code as classified by the Harmonized Tariff Schedule. Now, if you look at the concentration of products strategic to the Made in China 2025 plan in the 2018 cohort and the 2019 cohort, you'll notice a striking disparity. In the 2018 cohort, there is a significant concentration of tariff products belonging to the Made in China 2025 plan. These strategic products, as I call them, make up 98.86% of all the products receiving Section 301 tariffs in 2018. In contrast, these strategic products in the 2019 cohort only make up about 35.53% of the cohort. So how would this explain cohort heterogeneity? Well, if strategic products to the Made in China 2025 plan are more likely to use rerouting as a response to tariffs, it explains why 2018 cohort products show higher increases in trade rerouting. After all, they have a higher concentration in the 2018 cohort. Now, how do we test this? Well, like in the first part, I use the same difference in difference regression, and I create a dummy variable called strategic. 1, if the product belongs to the Made in China 2025 chapters of products, and 0 otherwise. I then use that same triple interaction term as before, treats times post times strategic, to track any additional effects of being a strategic product has on trade rerouting increases post-tariffed. Now, if that strategic product mechanism holds, we should see that this term is positive and statistically significant. Do we? Indeed, we do. being a strategic product increases trade rerouting effects by around 1.6 to 1.7%, which is modest, but non-trivial. That's about 492,000 to 500K worth of rerouting. There's also qualitative evidence of the strategic product mechanism. There was a recent convention in Las Vegas that tracked a lot of these Chinese companies trying to sell their products, all of them belonging to this Made in China 2025 plan. One company such being Lucky Star Electronic Tech Co. They sell tablets, laptops, projectors, other types of IT equipment. And one of the spokespeople from Lucky Star Technology mentioned that some methods that Chinese companies would use as a workaround to the US tariffs was to ship products to a different country before sending them to America as a final destination, a practice known as transshipment. So there is evidence that Chinese companies and exporters are aware of this method and are actively using it to avoid and circumvent these tariffs. So there is strength that being a strategic product makes you more likely to be rerouted. And because they are in the 2018 cohort, that explains why we see more evidence there. Another potential mechanism that showed promise was the close ties mechanism, which states that countries that had higher pre-existing trade volumes with both China and the US were more likely to be conduits of trade rerouting, especially those in the 2018 cohort. Now, the logic behind this mechanism is twofold. Firstly, countries that already import high volumes of products from China provide the necessary opportunity for China to deflect exports of tariffed commodities to them due to the existing trade relationship and trade infrastructure. Secondly, countries that already export high volumes of products to the US provide China the cover to better conceal trade rerouting from customs authorities. After all, this is an illicit act that they are doing, so they want to hide it. Therein lies the opportunity for trade rerouting. Countries that both import heavily from China and export heavily to the US before the tariffs provide China with the ingrained trade opportunity and inherent cover to transship affected products to the US without paying the higher tax. Like the strategic product mechanism, I test this one in a similar way by creating a variable called tie, that is, one, if the intermediary country has a higher than average volume of a certain product, and zero otherwise. Now, if the close ties mechanism holds, we should see that this triple interaction term, treats times post times tie, is again positive and significant. But we should also see that these same close tie countries are more likely to trade commodities belonging to the 2018 cohort as opposed to the 2019 cohort. So what do I find? I find that, yes, being an intermediary country that had significant pre-existing trade with both China and the US were more likely to be conduits of trade rerouting post-tariffs for quantity, but not for value. Also, these same countries were 3.4 times more likely to trade products in 2018 cohorts than products in the 2019 cohort. So what are the major takeaways of this thesis? First of all, Trump's trade war tariffs in 2018 were not entirely effective at blocking access of Chinese goods to the US market. And despite what he might tell you, it wasn't because the tariff got paid. Second of all, this amount of trade rerouting increase was quite modest, and it's due to two different things: the kinds of products being tariffed, right, whether you're a strategic product or not, and which countries were already trading these products pre-tariff. So I know what you're all thinking. I've heard tariffs and trade in the news all the time. It's kind of clogged my senses by the news. But at the end of the day, I mean, why should we care? Why should we care about something seemingly so incidental as trade rerouting? After all, tariffs did increase trade rerouting, but it didn't increase it to a staggering degree, and illicit activity happens all the time. Well, I'd say that it's because the trade war is still going on. And as you have all heard, it's happening again in historic levels of tariff rates. Now, I started working on this thesis in the spring of 2024, and I had no idea what was going to happen in just less than a year. But since then, the international trade landscape has changed dramatically, especially after February 2025, when the Trump administration announced sweeping tariffs on $430 billion of tariffs, worth of tariffs on Chinese goods, and for the first time imposed a 10% tariff on all US imports, plus an additional reciprocal tariff on dozens of other countries. President Trump called this Liberation Day. Now, a key justification for these reciprocal tariffs was to prevent trade rerouting. However, this thesis finds that while Chinese trade rerouting does occur, it's modest. Tariffs only increased rerouting by a few percentage points. And so blanket tariffs of up to 60% seem excessive for a relatively small problem. Still, admittedly, trade rerouting is just one reason cited for the tariffs alongside concerns about trade deficits and protecting US industries. But ultimately, trade policy like this shapes international security. Tariffs have become a key tool for the US to assert economic power and influence over the global supply chains. But rerouting remains a challenge to their effectiveness. So I'd like to end on a quote from a recent story by the Washington Post describing tariffs and trade rerouting in 2025 by metaphor. You can keep putting rocks in, but the water is going to keep flowing down. So I challenge you all today to think critically about whether this trickle warrants liberation. With that, I'm open to any questions that you have. Thank you so much.
Professor Allen as well.
So Noah, you didn't anticipate all the tariffs that would be added after January 20th.
Did not.
Obviously, the audience for this presentation is a lot more interested now than before January 20th.
Mhm.
Can you say a little bit, this was not the point of your thesis, but can you just say a little bit about what implications this has for, the current set of tariffs and how you would advise both critics and supporters of them to behave in light of your findings?
I think so to speak broadly to the tariffs, I think that there's two main schools of thought about these current tariffs. One, that the tariffs is a long-term plan, and one that it's kind of a short-term fix. If it's a short-term fix to get trade deficits more in balance, that's a little bit more in line with what international economics would say. If it's a long-term strategy to kind of bring factories back to the US, that is operating under the assumption that the tariffs will stay in place indefinitely, because the second you take away the tariffs, all of a sudden my factory is becoming really expensive and I'd rather produce in China. So it really depends on which school of thought you're thinking about it in. And in relation to trade rerouting, I'd say that technically, yes, these reciprocal blanket tariffs do curb the risk of trade rerouting. But then you have to think about, are you cutting off your nose to spite your face? Essentially, there's trade rerouting happens, but in such modest quantities that imposing a 60% tariff just doesn't make sense. It's too much of a blunt force instrument. And so I would advise that perhaps as a kind of leveraging tool, maybe arguing that we can reduce these reciprocal tariffs as long as you agree to be more diligent about your inspection customs regime. Because right now, the reason why trade rerouting is able to happen to such a degree is because the rules of origin of these different intermediary countries are quite weak. They don't really check things. And so that's why these products are able to flow through. So I kind of argue some kind of quid pro quo that as long as you're being a little bit more diligent on these inspection regimes, that the reciprocal tariff can be rolled back.
If Professor Allen.
Well, first of all, congrats on a great thesis and great presentation. I guess my question is more from the China perspective. And in particularly, so if you could elaborate a bit on what the Made in China 2025, like what about that initiative you think led to this rerouting? And then also if it's worth it for China to engage in that kind of policy in this, the current world. Like, what do you expect? What do you think the Chinese authorities should do now? Is it worth it to kind of subsidize these industries to keep trading with the United States, or maybe develop other markets instead?
Yeah, great question. I think from the Chinese perspective, it really depends on which products you're talking about, because in the Made in China 2025 plan, they're really focusing on the high-tech industries. And so, to export these and to pivot to other countries might not be enough. The US market is still in high demand. To be able to have your Made in China 2025 plan happen, you have to be a global dominant exporter, not just to countries but the US, but also to the US. So that's why that strategic product mechanism is kind of something that offers a lot of strong evidence, because if you are trying to export these products and the US is imposing a tariff, there might be kind of a incentive to reroute, even though rerouting might cost you a little bit more in the short term. Getting these products to the US and undercutting American industries might actually be beneficial in the long term. And I would say that more so in 2018 than now, because in 2018, there wasn't these reciprocal tariffs. So there was a little bit more incentive to reroute through third countries. However, in the current scheme of the trade war today in 2025, I would say that there's less of incentive to reroute, most so because you've essentially put high tariffs on whichever country that you're trying to reroute anyway. And because China has been working very, very hard since 2018 to establish close economic partnerships and develop and build up the infrastructure of different countries. And so, this wasn't touched on in the presentation, but trade deflection is becoming more of a way in which China can cope with these tariffs. And the fact that we don't need to sell to the US anymore because we've built up the industry in another country, and they would happily take our projectors and legacy semiconductors and things like that. So less so now than in 2018.
Professor Liu here? Okay, let's go to Jim Golgar and then to Raina.
Yeah, hi, I'm Jim. Great presentation. Thanks so much. So I'm intrigued by this difference between 2018 and 2019. And if I understood this correctly, so China's sending the makeup of what they're exporting changes from 2018 to 2019 in terms of the types of products. And if one of the goals of the tariffs is to try to prevent China from exporting these strategic products, then didn't the tariffs work?
So I don't think that China was attempting to change the makeup of the products. What the strategic product mechanism is saying is that by nature, in 2018, Trump tariffed or targeted most of the strategic products in 2018, and then through 2019 just held those tariffs firm and then just added on more tariffs to other products. So I would say that the tariffs didn't work in the sense that 2018 products were mostly strategic products, and there were still trickles of those products getting through the US market. 2019 products, I would say that there are other explanations for why those products were limited to the US market, more so because China didn't care as much that, I can't remember what specifically was on the 2019 product, but China didn't necessarily care that palm oil was getting to the US. They wanted strategic products to get to the US. And so they're more likely to deflect that to other countries that wanted the palm oil more, or the garden hoses more, or things like that.
Okay, last question goes to Raina.
Yeah, so I know you mentioned earlier on you were testing 6 different mechanisms, and I'm just curious if you could talk a little more about the other things you tested for and why, like, what you thought of them, what evidence they provided.
Yeah, of course. So you see up here, these are the 6 different mechanisms that I tested. And essentially the preemption mechanism was testing the fact that, hey, well, maybe because China knew that the second round of tariffs were coming, they could kind of preempt it and start rerouting and find better ways to hide it so that it didn't get caught. I found that this was quite a weak explanation. The pivot customer mechanism was the same thing I was talking about with trade deflection, where yes, China did find other consumers of products, but they didn't discriminate against the type of product. So it doesn't explain why 2018 products were rerouted more than 2019 products, but it does reflect why there was less products going to the US post-tariff, regardless of trade rerouting. The pass-through mechanism is that even though the scholarly literature has concluded that actually there was almost a complete pass-through, so Americans paid most of the tax. I was looking at the discrimination between what types of products was China more likely to want to shoulder the burden of these tariffs, and I found that yes, they were more so for the 2018 products over the 2019 products. And finally, the product complexity mechanism is that maybe more complex products might be more difficult to reroute because they're more complex, but also provide more revenue. And so there's kind of this balancing act where, maybe it's harder to reroute this product, but I'm going to get more from it. And so I see that maybe a more complex product is slightly statistically significant in that it leads to more trade rerouting, but there's a high degree of uncertainty there, only statistically significant to the 10% level. And that's why I didn't include it on this presentation.
Terrific. Please join me in thanking Noah. I'll take a minute for turnover, and if you're going to talk and catch up with each other, can you please go downstairs into the main lobby to do that, just so there's much noise from this lobby. Thank you all.
Great job.
Yeah.
Oh gosh, a lot to get there in 20 minutes. I was gonna call. Well,
Good job, Noah. You got Better?
All right, I think we're ready to get started. Last presentation of the cohort, so by no means the only significance of the order of presentations is when advisors were available to participate in the presentations. So it feels good to be let in. Why AI companies join or decline voluntary safety commitments. Over to you, Divya.
Thank you. Good afternoon, everyone. My name is Divya Ganesan. I'm a senior studying computer and political science and a proud member of this year's CSAC cohort. Before I begin, I would like to take a chance to thank some people who have made this year truly unforgettable. My parents for instilling in me a love for education, my thesis advisors, Professor Jumerick and Professor Grotto, pushing my thinking, my mentors, Professor Calkin, Professor Ziegler, and Diamond, among many who have joined me here today and online, and my friends and family who have supported me throughout it all. It means so much to have you all here. Now, as Dr. Dracuna said, I'll actually be giving the last presentation of the cohort, and so I'd like to dedicate today's time to my fellow CSAC Honors Thesis cohort, who've done an incredible job, and I hope to be working with you one day in Washington, D.C. Without further ado, it feels good to be let in. Why AI companies join or decline voluntary safety commitments. I want to start off by explaining this title. My education started just a mile away at Bing Nursery School, where at the ripe age of 4, I was given the following book with a simple yet enduring message. It feels good to be let in. Little did I know that this preschool lesson of blogging can actually be used to explain how frontier AI companies today may approach safety and security. And while I imagined my meetings between Anthropic, OpenAI, and Google to look like this, 29 interviews over the past 2 months have actually showed me it may have looked more like this. And why should how AI companies interacting with the government matter to you and national security overall? You've all read the news. Federal, state, and international governments have struggled to effectively legislate AI, which has given powerful firms free rein to put the following at risk. Now, security today has a wide variety of definitions. For the sake of my thesis, I define these risks as first, in the national security sense, the potential for malactors to hack models and take data for valuable IP. And in a personal security sense, generative AI has produced interpersonal societal harm, with consequences spreading and spanning from spreading misinformation to mental health. So now I've given you a sneak peek into my thesis. Next, I will explain to you what happened with the 2023 White House AI commitments, the literature that usually explains how companies behave, the study I conducted, and what I found. And let's start with setting the scene. The White House has been in talks with companies like Microsoft and JP Morgan since 2021. But congressional stalling meant regulation failed to be passed, so they continued to work with companies outside of the sphere. I want to highlight some moments of 2023 specifically. After Saul Altman actually calls Congress to produce extensive regulation, 4 things happen. Number 1, in May, the Biden administration convenes what I like to call the Core 4. Number 2, in July, round 1 companies join. Number 3, in September, a series of round 2 companies join. And number 4, in October, Executive Order 14110 is passed to ensure safety and security standards for federal agencies. That means, besides expert control and research budget regulations, this means no enforceable legislation is passed for safety and security, leaving only a voluntary regime in place. In May, the White House National Security Council, led by Brad Buchanan, gathered 7 leading AI companies to sign this list of voluntary commitments. On the slides, you see an example of what this type of commitment looked like, but they were essentially a rule of guiding principles around safety and security for frontier models. Though they were not law-binding, companies who publicly signed risked FTC lawsuits if they didn't follow through with the commitments and the required reporting mechanisms. To keep it short, these commitments were somewhat of a performance. Tech leaders came to the White House, they wined and dined, and had a media flurry to show for it. And as I learned more about the how of these commitments came to be, I started to think of them a little bit as that Mean Girls cafeteria. The National Security Council established a cool kids table. Enterprise AI companies looked over with jealousy. And many small firms and legacy tech companies found themselves still waiting in the lunch line. So how do we explain this behavior? We can actually look to other industries. Malhotra and Monin's research on voluntary environmental programs, or VEPs, demonstrated that industry-wide self-regulation can effectively dissuade government officials from seeking stricter regulations. Their study found that companies' implementation of VEPs can reduce public support for mandatory regulations by up to 20%, especially when all companies within an industry participate. We can also look to the chemicals industry's Responsible Care Act, initiated after the 1984 Bhopal disaster. The industry spent $40 million on a 5-year communication campaign paired with voluntary commitments to rebuild consumer trust. And this isn't the first time the government has attempted security pledges with tech companies. In 2015, President Obama, undoubtedly with the help of my former boss and cyber czar, who's online today, Michael Daniel, came right here to Stanford to ask companies to participate in information sharing and adopt voluntary cybersecurity procedures. The traditional economic literature thus suggests that there are many benefits for large companies to join voluntary commitments, and in contrast, diminishing returns for smaller companies like startups who have less capacity. Which leaves us with a puzzle. Why did some firms, like Oracle, fail to join these commitments? Consequently, why did some small companies, like Inflection AI, join? Thus, my research question. And in order to solve this puzzle, I bring in a new area of literature, namely FOMO, the fear of missing out. Professor Amna Alabri describes this concept as the need to belong, perceived group centrality, and the fear of social exclusion. Rifkin, Chan, and Kahn suggest that FOMO is less about specific experiences and more about missing opportunities with the people we care about. She and Wu expand this to organizational culture, showing how fear of missing career opportunities or technological advancements drives constant connectivity and digital engagement within companies. Ben Dooley describes how businesses experience FOMO when they perceive competitors gaining advantages through digital technologies. FOMO, in this sense, because of an accelerant of reactive rather than deliberate planning. as companies rush to adopt digital strategies hastily in response to valuation pressures from other actors. Now, for the sake of my thesis, I also introduce another term, phobia, the fear of blending in, defined as the need to stand out as a reaction to a lack of belonging by one Divya Ganesan. So they'll especially come into play as we unpack my third empirical chapter. Which brings us to the interviews. Over the last 9 months, I conducted 29 semi-structured interviews with policy leads and CEOs at these AI companies. My interviewees included everyone from Sean White, CEO of Inflection, to Ben Buchanan, the man who created the commitments in the first place. I also analyzed the web page language from companies included in the commitment. I pulled transcripts and web script data together to put a qualitative quoting analysis using NVivo and Atlas.t. And I sought to test the following hypotheses based on the literature. Hypothesis 1, interview subjects from companies that joined the commitments will say their firm was primarily driven by a need to preempt regulation. This is based on that Malhotra and Mona study I mentioned earlier. Hypothesis 2, interview subjects from companies that joined the commitments will say their firm was primarily driven by peer pressure. Think the FOMO literature I mentioned. Hypothesis 3, startups will say their firms were more hesitant to join the commitments than large firms. Literature I can describe in the question section. And hypothesis 4, interview subjects from firms that did not join the commitments will say their firm's primary driver was skepticism of the government's understanding of AI technology. The TLDR mentioned here. Which brings us to my findings. What did drive company behavior? Some findings, like signaling to consumers, were supported by my literature, but others, including FOMO and the importance of internal vision, surprised me. And for the sake of this presentation, I will be focused on the FOMO and phobia aspects, but I'm happy to talk about the supplementary material and drivers after the presentation. Let's start with the first adopters. The round one companies I like to call the first adopters, who in May were welcomed into the White House Cool Kids AI Club. Notably, 6 out of 7 of these companies mentioned security or safety on the front page of their websites. Across the board, firms in interviews expressed doubts about the government's expertise and efficacy, often criticizing its regulatory efforts as performative or overly restrictive. The skepticism was particularly strong among newer frontier AI companies who questioned the technical competence of government officials. It's got to be based on science, remarked an interviewee from OpenAI. Even established firms such as Meta highlighted unresolved tensions stemming from prior regulatory conflicts, which further strained trust. While the economic literature suggested that competitive pressure would drive companies to join the AI commitments, interviews revealed an unexpected and more personal dimension. Many companies cited feelings of FOMO and desired to be part of what we called the White House Cool Kids Club. Notably, large and small firms approach this dynamic slightly differently. Larger companies, accustomed to being included in major policy discussions, exhibited a sense of entitlement and were surprised when they were excluded. Smaller or newer companies, by contrast, expressed excitement and pride of simply being invited to the table. This dynamic aligns with Rifkin, Chan, and Kahn's framework, which frames FOMO not just as anxiety over exclusion, but as a driver of proactive behavior in a competitive, high-status environment. Which brings us to round 2, the next frontier, who in July were welcomed to the White House Cool Kids Club. Notably, 7 out of 9 of these primarily non-AI companies had AI on their front page. Only 2 out of 9 mentioned security. It's important to note that the round 2 commitments were slightly different and focused on number 1, content authentication, number 2, cybersecurity, and number 3, harm prevention. And even as round 2 companies accepted their roles outside the frontier model spotlight, many expressed a growing sense of exclusion. Though they understood why the government had focused its initial attention on firms like OpenAI and Anthropic, round 2 participants began to feel that policy conversation was drifting too far towards a narrow definition of AI risk, one that left enterprise and deployment-focused companies on the margin. The result was a palpable sense of FOMO, not just fear of missing out on a regulatory milestone, but concern that their technological relevance and civic legitimacy were being questioned. Yeah, this quote over there hurt Adobe's feelings, as I found out in my interview. Which brings us to the last group of companies who held out, the rebels with a cause. As an obvious answer to why they didn't join, they weren't asked, some of them at least, but some of them were. Which brings us back to phobia, fear of blending in. These companies did not reject governance per se, but resisted the social and political implications of aligning too early or too easily. For example, Oracle and Apple. These companies sought to distinguish between substantive engagement on AI safety and what they perceived as superficial or symbolic acts. In doing so, they positioned their non-participation as a principled stance rather than a sign of disengagement. As a representative from AMD, a semiconductor manufacturing company, said, for instance, while the other company had signed other documents on safety, the White House commitments felt like a flashy piece of paper that was not particularly relevant to the company's work. Similarly, Oracle, a cloud infrastructure company, dismissed the initiative as a big press release filled with platitudes that don't mean anything. As one executive put it, do you invest time and effort in signing a big press release? Or do you just go and do the work? But Intel, a company who was not asked to join, their outlook suggested that there may have been an underlying question the companies faced. Do I really belong in this group? I've just given you a lot of information. Here's the last 15 minutes on one page. I'll give you a second, soak it all in. And here's what I really want you to take away. Particularly for startups and less established firms, the decision to join was not merely a response to incentives, but an act of identity formation, a way to be seen, to belong, to not be left out of a historic moment of AI governance. And to return to my initial hypotheses, two hypotheses were supported. Firms around two were often motivated by desire to preempt future regulation, hypothesis one, and companies across both rounds consistently described peer dynamics, visibility, and reputational pressure as central to their decision-making, hypothesis two. At the same time, two hypotheses were challenged. Firm size was not a reliable predictor of hesitancy to join, hypothesis three, and non-participating firms were less skeptical of government capacity than they were strategically resistant to the symbolic and political meaning of inclusion itself. That's hypothesis four. So, what can we do with this information? The stakes are high right now. The current administration seems keen on supporting AI companies, but not necessarily setting standards. And here would be my message to regulators. First, we can fight the perception of voluntary commitments being toothless by designing tiered commitments that unlock exclusive influence to regulatory design. Second, we can include startups and small players in opt-in tracks to actually create greater system buy-in. And third, we can leverage consumer signaling and FOMO in how we do commitments, namely making them public, recognizable, and having concrete reporting mechanisms. So I'd like to conclude with a story. Last month, Jamil Jaffer, one of my mentors, came to CSAC to give a talk on the Trump administration's laissez-faire approach to AI regulation. His main claim was that we cannot have effective AI innovation with excessive regulation. And I don't completely disagree. But what I've learned from this thesis is that the future of AI policy is not a binary, but perhaps rather a spectrum. And in aligning companies to act in the interest of American national security, to be secure by design, we may not only consider only the quantitative, monetary, and legal incentives, but also something much more simple and human. What it feels like to be let in. Thank you, and I welcome your questions.
Great. So about 10 minutes for questions, and by CSEC tradition, the first couple questions go to Divya's advisors. Professor Durmek here? Yeah. Okay, Andy, why don't you go ahead?
Great job. How much work goes into these, and it's just been awesome seeing this project evolve for the past 9 months, and you know, contribute what I can to your brilliant thesis. I was struck by Intel. You know, and Intel's a fascinating company because they're, you know, at the same time that they weren't asked, they have people at Intel who are very close to the Biden administration. And, you know, people feel FOMO. Corporations aren't people, despite what Mitt Romney once said. And I'm so wondering how, you know, in your discussions with the interviewees, like how that sense of FOMO is sort of transmitted through an organization. Like how did, you know, I mean, clearly it's personality driven on some level, but is it possible to generalize about, you know, is it like one person driving the train in your cases? Is it a group of people who sort of come around to, yeah, no, we can't miss out of this? I'd love to hear you elaborate on that.
That's a great question. And there are probably 2 things on that I want to mention, which is the difference between how organizationally startups versus large firms responded, which is that a startup, given that largely they didn't have policy teams, had one CEO making most of the policy decisions. And with the culture of the CEO and character, individual FOMO for that literature was actually the most important thing. And so for many of them, let's say Inflection, they didn't have huge discussions. They had one person making a decision and following through. Personal FOMO that seemed to be the more driver there. Now with Intel, a larger corporation, the FOMO came more from the side of the Rifkin-Chan, Ben Dooley framework, which was the idea that, hey, we're a large company. We matter. We've been included in this before. We're kind of entitled to be part of a commitment like this. In fact, IBM said a very similar thing because they weren't included in round 1, but really asked to be included in round 1 between me and you. I didn't get that. And so what we found was that the sense of FOMO didn't come from a personal need, but from a company reputational standpoint, and was actually super tied to the consumer signal literature. So actually not super surprising.
Okay, we have time for a few more questions. Let's go to Joshua and then to Sophie.
Great job, Divya. 2 good questions. One, do you think there's a difference in the response between consumer companies like Google or OpenAI versus more business to business businesses like AMD or Intel, where they're not actually directly interacting with the consumer, but more just with other businesses, and perhaps they're not invited to the table, they're not as incentivized to join? And then the second is there a financial component to this, especially for publicly traded companies, where if they're have a big press release, there's an uptick in a share price or whatnot? I'm very curious about that.
Those are 2 great questions. Thanks over there. And there's a couple of things that I want to show. So what I didn't show you, and Josh, you hit it on the nail, which is that consumer and enterprise companies acted really differently. While both felt FOMO, consumer signaling was way more important to the round 1 companies, and internal vision as well than the round 2 companies. And they have, okay, perfect. I have a couple of quotes actually. So you had consumer companies saying things like, we are an AI first company. We are driven by a deeper need to focus on AI safety considerations. And what was really interesting about the consumer companies is that many of them had actually been founded on the basis of security and safety. I'm putting in a quote here from Dario Amodei, because I think the AI space is unique in that so many companies were founded on the basis of security and safety actually being a consumer value add. What you saw on the flip side was that enterprises were more driven by FOMO, not because, again, seen by the web pages, they necessarily prioritize security and safety by themselves, but because they had a third-party incentive to compete with the other companies who were in the area. And I can talk about that a little bit more with systems theory. Your second question was really good. It was on quantitative data and kind of the monetary sense as well. If I had more time, and if I were telling someone to do more research, I would look exactly at how stock prices jumped when each of these companies joined the commitments. It's kind of what IBM implied there. When the companies that joined round 1 were kind of labeled the gold standard of AI. enterprise companies don't care what the American public think. They do care about the federal government, who often is their consumer, and other companies knowing that they have the gold standard as well. My prediction to you would be that most of these companies' stock prices went up as soon as they had their announcement of the pledge. Your questions.
Okay, let's do Sophie, and then I have Herb Lynn after, and then I'll add Mike Toms, and we might end there. I think we've run out of time. So, but short questions.
Yes.
Sophie.
Congratulations, Divya. I'm curious if you have any sense as to whether these FOMO and phobia mechanisms transcend to organizations that aren't AI companies. And I'm also wondering, like, to what extent do you think that the US government can leverage these mechanisms to like better protect national security?
So short answer to your first question, yes. And unfortunately, there hasn't been enough research on the social psychology, Ben Dooley, Rifkin Chan Khan, exploration into business development. I think why emerging technologies are the easiest way to study a concept like this is because so much of their presence is online. And we didn't see the same thing with the chemical industry and earlier environmental industry, where we see a lot of the other kind of voluntary regime commitments come up. And remind me of your second question really quickly.
Yeah, like to what extent can the US government sort of leverage the sense of FOMO to better ensure national security interests?
So great question. I mentioned a couple of things on the policy implication side, but I think the main point that I wish the US government could see was the idea of thinking of companies not as individual elements, but as a system. And I had the chance to work with a couple other students here, with Professor Calkin specifically, on thinking about how do we think of regulation in a systems thinking perspective. The second quote I think is what's most important, is that the most critical component of a player's relations with another often lies in the relationship each possesses with the third party, which is that the government will overfixate on what the White House, how the White House connects with, for example, OpenAI, but you should really be focusing on how is OpenAI connected to Anthropic, Google, and IBM as actually a clear factor and how willing they are to approve decisions. So I would focus actually more on those intercompany relations.
Sure.
You started to answer this question earlier, but I wanted to draw it out a little more. What evidence is there that valuation, stock prices, et cetera, are actually affected by perceptions of a company joining these, regulatory regimes? What evidence is there that actually matters to significant financial bottom lines?
Absolutely. Yeah. And that's the kind of hitting the question on the line, because since this whole idea of secure by design would then imply that those incentives have to be aligned. So as I mentioned with Josh, there's a huge study from HAI and the MIT Technology Review that would offer some data to support that stock prices do go up, at least initially, when you sign a pledge. But this doesn't happen with every pledge. So Emily and I actually worked at CISA for a summer. And when you saw companies sign their Secure by Design pledge, the same stock price thing did not happen. Nobody saw a change in that. Somehow those 7 companies, specifically in round 1, each saw an increase. I'm not sure about the round 2 companies. That would be more further research, but they did. And that's what made round 2 companies have FOMO. What that tells me more than anything is that any voluntary regulatory regime isn't going to affect stock price or have an inherently good incentive. What will is a type of voluntary regime that creates a type of public, not only frenzy, media attention, but intergroup relation. That type of voluntary regime does create a stock price increase. And that would, to your point, seem to say that innovation and regulation doesn't have to be a dichotomy. It can actually be synergetic in sometimes. And perhaps the value proposition for companies can be security and safety.
All right, and let's go to Professor Toms for the last question.
Super interesting thesis, great job. I guess in theory, if a company was contemplating taking voluntary action and was thinking about it in terms of incentives, it would think about benefits in terms of cost. So I have kind of a 2-part question.
Yes.
One about the benefits and the other about the cost. If one of the benefits of voluntary action is that it helps preempt government regulation, could a company get that benefit by sitting on the pipeline? they succeed, the larger companies succeeded in preempting government regulation by taking voluntary action. So that's on the benefit side. Can you get the benefits without having to take any voluntary action? And then on the cost side, I was curious if you could clarify a little bit more, what exactly are the costs assigned to this paper?
Clarify. Also, many of them did. I wasn't surprised by this one. I think a data breaks. How does an inflection in scale and stability go into these commitments, but they can just stay on the sidelines and get the same benefits, and they don't have a policy? I talked to them, and then FOMO seems to be the primary driver of that. So the two puzzle questions I asked is, why did small companies join? Why did large companies who would usually join not join? So I don't know if that clarifies that first part a little bit. Your second question is also really important. What is the actual cost of not doing this? Now, the cost I mentioned in the beginning was that even though it's a voluntary commitment, these companies risk FTC lawsuits if they don't follow through on the reporting mechanisms and you do sign on. So there is a tangible disadvantage to that. But Oracle and Apple are correct to say that it could be a bunch of platitudes. You know, like once the Biden administration is done, do they still have to do this? What's actually interesting, let's see, I have one here, is that even though the Biden administration is long gone, these commitments actually are not enforceable anymore. There's no FTC regulation. Companies like Salesforce and Anthropic are still following through with them. And my hypothesis there is that AI companies have been built differently from the get-go to understand that security can be their value proposition. There's another element there that I want to talk a little bit more about with the cost. I know we're running out of time, but I'm happy to talk about that after the presentation. Thanks, Professor Toms.
Hey, everybody, please join me in thanking Divya for that.